Let us look at this interesting problem that we have over here. We have to prove that tan inverse of this fraction over here is pi by 4 minus half of cosine inverse of x. Tan inverse and cosine inverse are just the inverse functions of tangent and cosine respectively, and they are also known as arctan and arccos in some contexts. For those who do not know, just a quick review. So if cos theta is A, then cos inverse A is theta, and if tan theta is B, then tan inverse B is theta. So this is what we mean by inverse functions. In this proof, we will call the left hand side as LHS, left hand side, and the right hand side as RHS, and we will simplify both LHS and RHS and arrive at a common and prove that they are equal. So let us first start with LHS. So we can see that this is tan inverse of some fraction, right? So this will give out an angle, correct? So what angle will it be? Let us see. Just a moment. Okay. So we just for the sake of simplicity, call this numerator as O and this denominator as A. Okay. So the LHS is actually tan inverse of O over A, correct? And okay, let us just mark this, and so this will give out some angle. So let us draw a right angle triangle. Say this angle is, say, theta. Okay, so if this angle is theta, what will be the tan of theta? Tan of theta will be the length of this opposite side by the length of adjacent side. So effectively we can say that the length of this side is O and the length of this side is A, right? The opposite side and the adjacent side. That is why I took the variable names as O and A. So if the length of these sides is O and A, then this angle will be theta, right? Because tan of theta is O by A and tan inverse of O by A is theta. Now let us see what is the length of H, the hypotenuse H. So the length of hypotenuse can be found out from the theorem of Baudhayan, or also known as the theorem of Pythagoras, but now it is well known that Baudhayan knew at least some part of the theorem of Pythagoras much before Pythagoras. Baudhayan was an ancient Indian mathematician. Therefore, some people like to call it the theorem of Baudhayan. So from the theorem of Baudhayan or the theorem of Pythagoras, we can say that hypotenuse is root of O square plus A square. In our case, we know that O is square root of 1 plus x minus square root of 1 minus x, and A is square root of 1 plus x plus square root of 1 minus x. So you can see here, this was O and this is A. So we know O and A. So from the theorem of Baudhayan we can calculate the hypotenuse, which comes out to be 2. So you can square this and sum this up, and the sum will come out to 4 and the square root of that will come out to 2. So you can try this yourself if you want. So the hypotenuse is 2. right? So what is theta? We know that theta is tan inverse O by A, but since tan of theta was O by A, but we also know that cosine of theta is A by H, the adjacent side by the hypotenuse side, correct? So since we know this, we can also say that theta is cos inverse of A by H, correct? So the LHS, which is tan inverse O by A, which is theta, is also equal to cos inverse A by H. So the LHS has become cos inverse A by H, correct? Now let us see what is RHS, right? RHS is this. Now let us call the RHS. Now let us see, since RHS is this, what is twice of RHS? Twice of RHS is equal to pi by 2 minus what? Cos inverse x, right? Since RHS is pi by 4 minus half of cos inverse x, twice of RHS will just be pi by 2 minus cos inverse x. So twice of RHS is this. Let us call this as, see, cos inverse x is some angle, pi by 2 is another angle, so pi by 2 minus cos inverse x is also an angle. Let us call this alpha, right? Okay. So what is RHS? RHS is alpha by 2, correct? Now what was LHS? LHS was cos inverse A by H. RHS is alpha by 2. So effectively our problem has reduced to proving that cos inverse A by H is equal to alpha by 2. Okay. Now this can also be changed to, we can send the cosine here, so we can say that we have to prove that A by H is cos of alpha by 2, correct? So this is the new RHS and this is the new LHS, correct? So what is cos of alpha by 2? Let us try to see that. Cos of alpha by 2. This is what we have to find. For that, let us first see what is cos of alpha in terms of cos alpha by 2. It is cos square alpha by 2 minus sin square alpha by 2. It is also standard identity, but it can also be easily proven. If you are interested, you can get lot of resources on the internet, or you can ask me in the comments. So what is 1 plus cos alpha? Now this 1 can be written as sin square alpha by 2 plus cos square alpha by 2 and this cos alpha can be written from here, it can be taken from above, and it can be written as plus cos square alpha by 2 minus sin square alpha by 2. So this sin square alpha by 2 terms, these two terms will get cancelled, and we will get 2 cos square alpha by 2. So we can send this 2 over there, and we can write that 1 plus cos alpha by 2 is cos square alpha by 2, or you can just remove this 2 and put a root over here, correct? So cos alpha by 2 is 1 plus, so cos of alpha by 2 is 1 plus cos alpha by 2. So the RHS, which was cos alpha by 2, can also be written as, this can also be written as root of 1 plus cos alpha by 2, right? Now what is alpha? Alpha we have defined here, right? So we are now let us now simplify the RHS further by using the value of alpha. So RHS we know is this, and we can go further and say that RHS is root of 1 plus cos alpha by 2, which is okay. Instead of RHS, let us first see what is this cos alpha part of RHS, right? What is this cos alpha part of RHS? So cos of alpha is what? Is cos of pi by 2 minus cos inverse x. We know this because since alpha is pi by 2 minus cos inverse x. So cos of alpha is this, which is equal to sine of cos inverse x, right? Because cos of pi by 2 minus theta is sine theta, correct? So now how do we calculate this? We know that this is some angle whose cosine is x. So this is in a right angle triangle. This is some angle, say beta, the cosine of which is x. The cosine of beta is adjacent by hypotenuse. So adjacent by hypotenuse is x by 1, right? So the cosine of beta is x by 1. So what will be the sine of beta? Since cosine inverse of x is beta, so this is this angle, this is this angle, this is this angle because cosine of beta is x by 1. So and cosine of cos inverse x is also x by 1. So what will be the sine of beta? Sine of beta, again from the theorem of Baudhayan, the length of this side is 1 minus root of 1 minus x squared. So the sine of beta is what? Opposite by hypotenuse. So the sine of beta is actually root of 1 minus x squared, which is the opposite side by hypotenuse 1. So sine of beta is root of 1 minus x squared. But the RHS was this equal sign is giving this misconception that this is the LHS. So the this is the RHS since this was derived from here, right? So the RHS was root of 1 plus cos alpha by 2. What is that? Cos alpha we know is this. So RHS, which is root of 1 plus cos alpha by 2, is actually root of what? One plus square root 1 minus x square by 2. Correct? So this is the RHS. What is LHS? LHS is A by H, right? What is A by H? A by H okay. Sorry for the interruption. I had a little issue over here. So we know that RHS is this. What is LHS? LHS is A by H. Okay, so let us just see. LHS is A by H, which is actually root of 1 plus x plus root of 1 minus x by 2, and what is, say let us try to find out what is the square of LHS, right? So the square of LHS square is A square by H square, which if you solve this and simplify this, it will give you 2 minus 2 plus 2 root of 1 minus x square by 4, which is effectively 1 plus root of 1 minus x square by 2, right? You can solve this, try this. You can try this yourself if you want. So the numerator will directly simplify to this, and the denominator will, the 2 square is 4. So this is LHS square. What is RHS square? We know that RHS is we know that RHS is this. So RHS squared is also 1 plus root of 1 minus x squared by 2, right? So we know that RHS squared is just the same as LHS squared, correct? These two expressions are the same, right? So in this way we can prove that LHS is equal to RHS. So therefore, since LHS squared is same as RHS squared, we can prove that LHS equal to RHS, right? If there are any questions, please feel free to comment below. And sorry if the quality of video is either too slow or not very good, because this is my first video. So please allow me some time to improve. Thanks a lot, and thanks for watching.